All right, so let's look at number 91 from page 68. F of x equals absolute value of x times sine of x. The directions: use a graphing utility, calculator, phone, computer, whatever, to graph the given function and the equations y equals absolute value of x and y equals negative absolute value of x. Use the graph to observe the squeeze theorem visually and define the limit as x approaches 0 of that function. So my guess is that this function they give us is going to be sandwiched in between the other two. So let's look and see if that's the case. Perfect. This is similar to the last example we did. So I've got the first two functions already in there, absolute value and negative absolute value. And then absolute value of x times sine of x. So there's absolute value, there's negative absolute value, and here comes the weird one. It's kind of odd looking, but it's clearly sandwiched in between the other two, and then it gets squeezed at x equals 0, it gets squeezed down to presumably 0. Like, this isn't like a formal algebraic or calculus like proof, but that's okay. The directions just say visually figure out what that limit is. So it gets squeezed, sandwiched, however you want to phrase it, down to 0 by the squeeze theorem. Other questions? Yes.
Could you do 90?
Yes. 90. Yeah, that's a good one because that's in the other set, and it looks, there's not any numbers in that at all. So before we even start plugging things in, this definitely looks like sandwich theorem stuff because f of x is sandwiched in between these two things. And so it's going to get squeezed in between these two things at c equals a. Find the limit of f of x as x approaches c. Okay, well, I know nothing about f of x. So there's no graph to look at. There's no substitution to do. There's nothing I can do with f of x. I have no idea what it is, except that it's sandwiched in between these two things. So let's evaluate these two things at c equals a, but c is going in for x, so a is going in for x. So b minus a and b plus absolute value of a minus a. So this is just one of those sort of rigged problems where b is less than or equal to f of x, which is less than or equal to b. So I don't know what's happening with f of x. I just know that it's getting squished at c. It's got to be smaller than b and bigger than b at the same time. So the only place for it to go is b. So sandwich theorem, squeeze theorem, whichever way you want to call it. That's kind of the only way to ask those questions. So it's a nice concept. It's an easy concept. It's just hard to test because there's only so many different ways you can squeeze a function in there.